방금 발표한 스타트업은 스타트업 빌리지에서 만나보실 수 있습니다. 유익한 시간 되셨길 바라며 내일 시상식에서 다시 뵙겠습니다. 감사합니다.
For now, let me introduce our next speaker, Shuichiro Yoshida, the CEO of FRP Consultant Corporation. He has over 10 years experiences in aircraft engine design and is now CEO of FRP Consultant Corporation in Japan, offering engineering support for companies that operate in the composite materials business. His topic of this session is key aspect of drawings, material specs, and process specs for composites. We'd like to connect him through the Zoom, so please welcome him with a big hand. 여러분 큰 박수로 모시겠습니다. Hello, Mr. Yoshida. If you're ready, you can start.
So the title of key aspects of drawings and material specs and process specs for composites. So I'm Shuichiro Yoshida, CEO of FRP Consultant Corporation. So I have more than 15 years experience about composite industries in Japan, the United States, and Europe. And so the range of the industries are aeronautical, electric, automotives, and industrial applications. So our main skills are supporting about the composite technologies, and the other one is engineering education support for a wide range of industries. So that's why I have two different kinds of the business categories. The first one is the FRP consultant, mainly engineering support for composite technologies. And the other one is engineering education. So that is not limited to composite industries. So our headquarters located in Saitama, next to Tokyo in Japan. So today, I have three topics for this presentation. The first one is the background issues in composite industries. And the second one is design practice for composites. And the last one is three key engineering documents and common misconceptions. So I'd like to start from the first topics. So there are many kinds of the composite applications like toy equipment in the park, chemical tanks in the factories, or coasters, or laboratory module in the aircraft, or some side spar for the doors of automotives, or complex shape for the construction, or water tanks. So in order to apply such kind of wide range of applications, so there are wide various kinds of the materials also. For example, mainly the reinforcements of composite would be carbon fiber or glass fibers. And that configuration is also very different. For example, there are the wovens, or braiding, or matting. So, and combined with these reinforcement fibers, so we could choose the mainly two kinds of different matrix resin systems. And the first one is thermosetting resin systems, and the other one is some plastic resin systems. And after combine both of the fiber reinforcements and matrix resin systems, so we could make the composite materials. And these materials would be layup by the fiber placement or hand layup. And also that layup composite material will be molded by autoclaves or high pressure resin transfer RTM, or some other molding process. Then these molded composite parts will be machined by the mechanical machining or water jets, just for trimming or making some holes. Then so these machined composite parts will be inspected about the dimensional requirement or some non-destructive requirement. So as I have mentioned here, so we have so many kinds of material technologies or manufacturing technologies, but the composite have not been spread as we have expected. So what is the next necessary for the next step? So cost reductions or productivity improvement. So maybe these items or these topics should be very important for composite industry spreading. But here today, I'd like to propose another viewpoint about design practice. So today, I'd like to explain about what is design practice. So to understand about from the basic point. And what is the design practice for composites? So there exists three very basic engineering documents when we discussed about design practice. And the first one is the drawings and material specs and process specs. And the design practice is only available when these three documents are available. So this is a very important starting point. And so what is the purpose of the documents? So I'd like to start from the material specs. So material specs includes a minimal essential requirement about the material properties or qualities or packaging requirement. And also the process spec is similar to the includes the minimal essential requirement, but only focusing on the process. So for example, process parameter control or the recording. And drawing is the highest priority requirement, and this document will refer both of the material spec or process specs. So this is the highest priority document, and that includes a dimensional or material or process requirement. So from here, I'd like to start discuss about these three documents about and also these basic structures. So I'd like to start about drawing at first. So this shows a very basic structure of composite parts drawing. So the main area shows about configuration of the parts, including the dimensional or geometric tolerance. Then the visual inspection also included, and also non-destructive inspection requirement, then drawing note, and process spec or material spec number also mentioned here. Then supply table also defined about the layout configuration here. Then the drawing number or name will be also mentioned here. So as I showed as a red letters or red rectangles, so about these red focusing areas or letters is sometimes observed about some issues from the design practice viewpoint. I'd like to explain about these points. So red circles areas shows some often observed issues in the drawing. And the green lines, green areas shows us it's this countermeasure against these issues. So mainly about drawings, two main issues about it. The first one is lack of necessary requirement, and second one is inappropriate requirement. So I'd like to start about the lack of necessary requirement. For example, so sometimes no dimension tolerance has been observed. So maybe as you can imagine, it's very difficult or costly, impossible to mold or manufacture the molding the composite parts, because of course they have process variance. There also dimensional inspection has itself has their variance. So maybe the drawing needs to include the dimensional tolerance at the same time, so including the some in considering some variance about the process or inspection process too. And about no visual inspection, so this sometimes happened. So only from the composite engineering viewpoint, so visual defect is not so important because composite has very unique properties like anisotropic properties. So visual defect is not sometimes happened for the fatal failure, but visual inspection is very easy to find out because we can detect the defect from the eyesight, so from the outside. It's very easy to find it out. So customers sometimes claim about the visual inspection, so drawing should define clearly what is the visual requirement and what is the visual inspection requirement. So such kind of requirement also should be included in the drawings. And third one is a non-destructive inspection. So it's also sometimes very important point about design practice in the drawings. So composite has anisotropic properties, as I have explained. And one of them, the rule of the failure or fracture is very important. For example, if there exists very small defect inside of the composite parts, that would be the origin of the crack propagation during the application usage. So designer should detect the inside defect prior to the shipment because they need to avoid such kind of internal defect, which can be the origin of the fatal failure. So basically, when especially the designer would like to apply composite parts for the structural parts, so non-destructive requirement should be also mentioned in the drawing. This is a countermeasure about it. And the no layer pattern definition is also sometimes happened. So for example, composite has anisotropic properties. And so for example, about the unidirectional composite material, they have very strong strengths or modulus properties for the fiber directions. But about the vertical directions, they have very weak or very low properties about it. So the composite parts, molded parts, performance has been very strongly dominated by the what is the layup angle, fiber angles, or also how many the layup or how many plies will be used with the composite parts manufacturing, or also what kind of the material will be used for the layup. So we need to define such kind of fiber angles, material angles, or layup number, and also material properties or material name should be defined in the material ply table. So we need to, the designer should define about the ply table to detect, to define what is the proper layup configurations. And second one is property requirement. So material commercial name reference, detail process parameter mentioned. So these are also very issues about it. So we need to refer the material spec number name against the material commercial name and the detail process parameter name. So process spec number should be referenced. So about material commercial name, so if the material commercial name of the manufacturer is referred in the drawing, it's very big issues because all of the material quality systems will be dominated by the material manufacturer. And also if the material manufacturer suspend manufacturing the materials, so it's very difficult to find out the other other alternative materials because commercial name is only referenced in the drawing. In that case, also we need to, or designer needs to revise or change the drawing requirement. It's very big impact so they have already started the production. So material spec number, including the requirement, should be referenced. And that material spec number will not define the or some requirement about the commercial name. So material spec original number will be referred. Also, detail process parameter dimension is sometimes issues. So for example, if composite molded manufacturer supplier would like to change the molding temperature from 180 degrees C to 190 degrees C. So it's not difficult. It's very difficult when the drawing defines a detailed process parameter about molding temperature, for example. So such kind of process optimization is sometimes necessary to improve the productivity. So to allow such kind of the process parameter modification, so drawing should only differ the spec number, not detailed process parameter. So I'd like to explain about it further later. So about the material specs. So there exists so many kinds of the public material specs, but about composite material specs, there no exists about the public material specs in all over the world. So we need to prepare material specs by ourselves. So what is the main topics or main element need to be included in the material specs? So 5 elements: the package, material properties, visual inspection, evaluation record, and the test method. So about material properties, it's very easy to understand why it's necessary, because the material properties needs to be clearly defined in the material specs. But the point is that material properties requirements should combine with the test method, because the test method has impact on the test result, I mean the evaluation test result. So these 2 elements will combine strongly when the requirement is mentioned in the material specs. And also package is also very important. So for example, if some material composite parts manufacturer would like to use some setting resin systems composite materials, but they need to storage that materials when the material is not used. But the size of the internal size, so the freezers is 1 meter maximum, for example. But if the some setting composite materials package width is 1.5 meter, for example, this material is not stored in the freezers, because the material is bigger than the freezer size. So to avoid such kind of the conflicts, so we need to discuss, the designer and customers and the composite parts manufacturer needs to define what is the maximum size of the package. So such kind of discussion also needs to be included in the material specs. And visual inspection also very important. So it's very similar to the drawing. So material outside and the visual defect is also needs to be clearly defined prior to the shipment. So to avoid the conflict with customers. So material manufacturer needs to discuss prior to shipment with customers about visual inspection clearly, then mention the material specs. And the evaluation record is also important. So these are, for example, the shipment, material property test result, also some storage conditions prior to shipment. What is the storage condition prior to shipment, for example, after the pre-pack is prepared, for example, how long and what is the temperature condition, so prior to shipment about that material. Such kind of the evaluation record also needs to be included in the material specs. So it's also similar discussion about the drawings. So mainly 2 issues about the material specs. So lack of necessary requirement and no material specs. So the first one, no requirement tolerance, is very similar to the drawing. So temperature, pressure, storage term, glass tension, temperature, strength, modulus, or Poisson ratio needs to be defined with tolerance. So such kind of tolerance is very important. And also, visual inspection is also similar to the drawing. So such kind of visual inspection result requirement also mentioned is material specs. And no chemical analysis. So composite material consists of 2 kinds of the materials. The first one is the reinforcement fibers, and the other one is matrix resin systems. And material excavation systems conditions, so we cannot understand what is the status from the visual inspections. So, for example, FTIR or some chemical analysis requirement needs to be mentioned in the material specs to understand whether there exists no chemical construction or chemical configuration change or difference between the already shipped materials. Such kind of a comparison evaluation result. So chemical analysis requirement is sometimes necessary to do it. And last one is the packaging mentioning. So as I have mentioned, the package size or some configuration needs to be clearly defined prior to shipment. But mainly, so no material specs, that is very often observed of actual design practice. So the designer needs to prepare the material specs, and that material specs includes the original spec number and also clearly defines the engineering requirement, as I have mentioned before. So from here, I'd like to explain briefly about what is the material spec constructor. So for example, this basically the material spec start from the scope that mentioned about the summary and the purpose of the prepared material specs. And there was some reference standard also mentioned here to clearly define what kind of the test method or what kind of standard should be applied to the evaluation. And definition is also very important. So to avoid the misunderstanding what is the meaning of the word. So also the quality assurance, if the designer needs to have some requirement about the quality, so we need to mention about ISO 9000 or some aeronautical standard requirement will be also mentioned here. And also material requirements also mentioned here. So as I have mentioned, this is a requirement example for carbon fibers. So tensile strengths, modulus will be mentioned here clearly about the quantitative requirement. And the tensile modulus, for example, has the tolerance 210 gigapascal plus minus 15. So such kind of requirement tolerance is also necessary. And also both of the requirement linked to the test method. What kind of the test method needs to be applied. So such kind of clearly combined combination is very important when the requirement will be mentioned. So there's also material shipment test result. So what is the tests to be necessary? So such summary will be mentioned here. Also, test panel fabrications is also mentioned here. So prepare necessary number of the test panels because most of the composite properties prior to the shipment will be conducted by test coupons. So to prepare test coupons, so we need to get the test flat panels. So we need to define how to prepare test panels because the material property will be affected by the temperature or pressure or the profile, manufacturing profile has some impact on the performance. And the cured composite property tests also mentioned here, but also some summary of the test method or what the requirement also mentioned here, even though the test standards will be referenced. And packaging also mentioned here. So as I have mentioned, for example, packaging size will be clearly mentioned here, like 1,000, less than 1,000 millimeter or something like that. And the last one is the process specs. So process specs has very many kinds of the requirement element, like temperature, pressure, machine safety, layup, rework, facility inspection, recall equipment. So we designer do not include all of the requirement. So designer can choose what kind of the requirement needs to be controlled by the process specs. So we need to choose. And so the total summary requirement. So all of the requirements should also include the tolerance and the quantitative requirement, which is very preferred. And the explanation with images of photos also very important when we need to discuss about the process spec context. So bad areas are also similar to the material specs. Two main elements: lack of necessary requirement, and no requirement tolerance is almost same as the drawings and the material specs. So temperature, pressure, holding time, machine speed, and extra some process parameter requirement with tolerance will be used. And also no storage process data storage term. So it's very important. So when, for example, if some market issues has been happened after the mass production, so this process spec requirement is very important, because so the designer needs to investigate what is the origin of the market issue. So in that case, the designer needs to understand what there is difference between after the market issues happened and before market issues happened. So such kind of the difference, if there exists some difference about the process parameter, so that process parameter change would to be one of the origins of the market issues. So to achieve such kind of the requirement, so we need to process data storage term more than 5 years, or such kind of the long-term data storage term will be required in the process specs. And no image or photos, so sometimes it's very difficult to understand the detailed process requirement or conditions, only the letters. So we need to sometimes use some images or photos to easy to understand or to support the understanding of the content. And no process spec, so sometimes happened, and also designer needs to prepare the original spec number, setups original spec number, and that includes the process parameter control and recording requirement clearly, as I have explained. So here shows the basic structure of process specs. So scope, definitions, and requirement is very similar to material specs. And procedure, for example, this is the example for the molding process spec for molding process. In that case, pressure, top temperature, or molding speed will be some parameter requirement with tolerance is mentioned here, like this one. And recording requirement, so that here, so 5 years requirement will be required here. And also I recommend to input this requirement. So process parameter will be recorded both of the digital and paper-based. So this is decrease the risk of the erase of the process parameter details. So such kind of requirement is one of the candidates to be included. So I hope so such kind of the design practice with the drawings and the process and the material spec would help composite industries, and also that would be lead to the clear or more better futures. I hope so. Okay, thank you for your attention.
Thank you very much, Mr. Shuichiro. If there's any question to him, you may raise your hands and he will answer to the question. 혹시 질문이 있으신 분 계실까요? 네, 없으시다면 이 세션은 이렇게 마치도록 하겠습니다. Thank you very much.
Thank you very much.
And now I'd like to invite our next speaker.